Hey, last video we kind of got into a little bit about what a phase change is. And a phase change, again, is really nothing but when something turns from a solid to a liquid to a gas. And we introduced you to a new equation, Q equals ML, that looks like this, where L can either be an LF or an LV. Now, this is where people sometimes get confused on this. I kind of teach it where it's this LF and LV can be either a positive or a negative. I'm going to go, and I don't remember if this is in the last video or not, but I'm going to kind of break this down a little. And I'm going to write solid, liquid, and gas. And I would suggest you kind of keep this little chart kind of handy as you do these problems. Because what you've got to keep in mind is this. Like I said, everybody just gets confused over the LF and the LV thing. Well, a solid to a liquid or a liquid to the solid. This is talking about an LF, latent heat of fusion. And then if you get into a liquid or a gas, this is where we're talking about vaporizing something. So we call this an LV. But here's what you got to think about. If you can turn a solid to a liquid and a liquid into a gas, you should be able to do the exact reverse. We should be able to take a gas and condense it back to a liquid. Well, here's the thing. In order to turn the gas to a liquid, I'm going to write negative LV. We're going to need to remove energy from that system. And the same thing, if we want to turn a liquid back into a solid, I'm going to write negative LF. We're going to need to remove energy from that. And so as we do these problems, it's going to come in kind of handy to keep this in mind. All right, these next problems we're doing, and there goes the bell. I guess class is over. I'll see you later. Well, anyway, these are probably the hardest problems in Chapter 11. There's going to be two types of questions as we do these. There's going to be a type of the questions that we work where we work plain old sum of the Q is equal to 0 type problems. And you've already done these problems before. But there's also going to be a type of question that looks like sum of the Q equals, I'm just going to write a question mark, because that's what we're going to be looking for. And right off the bat, you should be wondering, okay, how do I know if I'm going to do the sum of the Q equals 0 or the sum of the Q equals what I'm looking for? If the question asks you to find energy, if the question just comes straight out and asks you to find energy, that's going to be this one, where you're actually doing a sum of the Q's. The first questions I'm going to teach you are these kind, because they're the easiest of all these. And don't get me wrong, the reality of it is, I don't think any of these problems are easy. Mathematically, these problems are the easiest you've done. If you've just watched 11 chapters worth of these videos, by far, this is the easiest chapter of them all. But here's what we're going to do. We're going to start out with an ice cube. And you're going to have to think as we go through this. I'm going to start out with a cube of ice. And I'm going to start out with a cube of ice at negative 30 degrees Celsius. So here's that cube of ice at negative 30 degrees. And we could give it a mass, 10 grams. It doesn't matter at this point. Here's what I want you to do. I want you to try and boil away this cube of ice. This is what most people don't think about. There is a lot goes into trying to make this cube of ice and turn it into steam. I'm going to do a little set of drawings here, and I hope this kind of helps you get it all straight. But it is very difficult, I'm not going to lie. Before I can melt a piece of ice, here's the thing. I cannot melt a piece of ice that's at negative 30 degrees. Before I can even attempt to melt this piece of ice, I've got to warm up the piece of ice. Well, what temperature is the ice going to be before it melts? Well, I'm going to have to get the ice to at least 0 degrees Celsius, which means the first part of this problem is an MC delta T question. In other words, I got to go in and heat this piece of ice up to the point where it has the ability to melt. Once I've heated the ice, in other words, it's going to take energy to melt that ice. Once I've heated the ice to 0 degrees, well, now I can actually try to melt Now I can actually melt the ice. So I can actually melt the ice, and let's come back and let's see if we can't turn this piece of ice into some water here. So I'm going to take this piece of ice, got to put it in a container, and we've melted it. And so now we've got liquid water over here. So we've melted the ice and we've got a liquid. Well, the cool thing is we've got an equation for melting something. If I want to melt something, the equation is MLF. So there's my equation for melting something. Now, this would be a good question. What's going to be the temperature of that water after it's been melted? Well, here we go. Here's the ice. It's 0 degrees. I'm going to melt it. This is the part that gets most people. After the end of the phase change, the ML, I'm going to have water, and that water is still going to be 0 degrees Celsius. So in other words, after the phase change, my temperature hasn't changed. So now, I want to try and boil away this water. So what's going to happen? So I'm going to kind of get my little arrow here. I'm running out of room. So I'm going to attempt to try and boil the water that was a piece of ice. Well, here's the thing. Before I can boil the water, look at the temperature right now. This water is at 0 degrees Celsius. You're in a Unit 11 of a physics class. What's going to happen to that water before I can even think about boiling the water? Well, before I can boil the water, I'm going to have to get its temperature from 0. I'm going to have to heat its temperature all the way up to 100 degrees Celsius. Once I get the water to 100, I can boil it. So I want you to look at something. I've got to heat the water from 0 to 100. Well, in order to do that, we got like 3,000 bells in this school. And they're all irritating. Once we get the water, we've got to get the water from 0 to 100, so that's going to take an MC delta T. I've got to heat it up. Now, once I've got the water, if you actually want to boil the water away, so in other words, now you actually want to turn this water into a cloud of steam. So I actually want to vaporize the water. I cannot spell the word vapor. I apologize. So I actually want to try and vaporize the water. Well, I can do that, but only after I'm 100 degrees. And the cool thing is I have an equation for vaporizing something. MLV. So there's my equation for vaporizing water. Now, this would be a great question here. Sometimes you'll get lucky and the problem will stop right there. MC delta T plus MLF plus MC delta T plus MLV. And the problem's over and done. You plug in all these numbers and you get an answer to it right here. Sometimes, though, the problem wants you to go a step further. They actually want you to heat up the steam. Let's go back to here. I had a piece of ice and I melted it. When I melted the piece of ice, I had a piece of ice that was at 0. I melted it, it became water at 0. Go back to here. I've got water that's 100. I'm going to vaporize it and turn it into steam. What should be the temperature of that steam? Well, this is just like the ice. 0, you melt it, it's water that's 0. If you've got steam, is 100 degree water to boil it, the steam itself should also be 100 degrees. Now, this is where the problem sometimes, and this is your biggest, hardest problem. The problem will then say, okay, I don't just want steam, I want some crazy hot steam. In other words, let's say that it wants you to get the steam heated to like 130 degrees. Well, look at what we've got. All we're doing is changing temperatures again, which means we've got another MC delta T problem. That is all there is. Now, I know it looks like that's a tremendous amount of stuff in this problem, and you're right, it is. And there's some catches to it. Some things we know, some things are going to be easy. LF, well, if this is water, I already know that LF is 80 calories per gram. Once again, if this is water, I know what LV is. LV is 540 calories per gram. So there's a couple of things that we kind of know here at this rate. We know what C for water is, don't we? So when I'm heating this water from 0 to 100, I know that C is going to be 1 calorie per gram Celsius degree. I know what C is going to be for this. Here's where people mess up. Here we've got an MC delta T. But remember something, this is a piece of ice we're heating. Ice is not the same as water. So what happens is C for this ice is not the same as C for water. So C for ice is 0.5 calories per gram Celsius degree. I know at this point you're thinking, wow, this is a lot of stuff. And it is. I'm not even going to lie. Well, you got to think. C for ice has its own unique value. C for water has its own unique value. What about when we tried heating up this steam? Well, you win again. C for steam is 0.48 calories per gram Celsius degrees. So every phase of matter has its own unique C. This is one of the hardest questions. If you've got this, then you're kicking it right now. I usually don't. This is not how I work the problem out as much, but it does kind of work. I like writing an equation to represent all this. How I represent this problem is this. I've got 1, 2, 3, 4, 5 Q's in this problem. So if somebody tells me I've got a piece of ice, and I do most of it in my head, but if they say you've got a piece of ice and it's at negative 30 degrees, I know that I've got to get that ice from negative 30 to 0. Before I can melt that piece of ice, I got to heat it from negative 30 to 0. After I've heated up that piece of ice, QLF, I know I can melt it at this point, and then LF stands for melting it. Well, after that, I can do a Q. Once I melt the ice, I know I've got this ice that was at 0 degrees, and before I can boil it, I'm going to have to heat it from 0 to 100. Once I get the water heated up to 100, I can do a QLV. I can now boil it. And then I can heat the steam from 100 to 130. And then I add every bit of that up, and I got my answer. This is really a little quicker way of writing it out. What it is, this is the way I would do it on paper, and it's much faster this way. Let's go ahead and work this problem and actually get an answer to this. So what I'm going to do is I'm going to go through and plug in values for every single MC delta T and every single ML that we've got in this problem. Let's just make this 1 gram of ice. Let's make this kind of an easy number in this problem. So here, my first Q is going to be 1 times, remember this is ice, negative 30 to 0, so my C is 0.5 times temperature final minus temperature initial, 0 minus negative 30. 0 minus negative 30. What's going to happen? Minus negative 30? So that's going to be plus 30. Now let's see. Plus QLF. Let's see. That would be 1 times 80. So 1 times 80. I love convenient numbers. Plus, now I'm actually to the part where I'm going to heat up the water. So I'm going to go M is 1 times 1 because we're water right now. And water has a acidity of 1. And we're going to go 100 minus 0. Well, 100 minus 0 is just 100. Plus LV. So now we're to the point where we boil it. MLV would be 1 times 540 plus, I'm running out of room, we got one more MC delta T. 1 times, we're steam now, so 0.48 times final minus initial, 130 minus 100, 30, and now I can put all this in the calculator and get my answer. Let's see if I can, part of this I may not even need a calculator for. 0 plus 30 over here is just 30, so that's going to be half of 30. So I've got 15 plus 80. 1 times 1 times 100. This is why we do calories. The units are a lot handier. 1 times 540 is 540. 30 times 0.48 is going to basically be 15, but let's get it exactly. 14.4. So plus 14.4. Now, if we add up every bit of these calories, 15 plus 80 plus 100 plus 540 plus 14.4, 749.4 calories. So if you were asked to take a gram of ice at negative 30 degrees, turn it into steam at 130, 5 Qs, grand total answer of 749.4 calories is our answer. Hey, these problems are hard. You got to work them. In terms of the sum of the Q questions, this is as hard as it gets. Because a lot of times what will happen is a problem will start you with a piece of ice at 0. Well, hey, that's awesome. If it starts me with a piece of ice at 0, I get to skip this entire first MC delta T. So I can literally start a piece of ice at 0, so I can just melt it. And once it's melted, I can heat up its temperature to 100. Then I can boil it, vaporize it. And a lot of times, they'll cut off this end. They won't even ask you to heat up the steam over here. But anyway, and you'll only have like 3 Qs. So this should be as big, 1, 2, 3, 4, 5 Qs as it gets. And in reality, it should. You shouldn't see anything bigger than this. Okay, well, this is how you do a problem where you're actually finding all your Qs. Next problem, we're going to make it a little harder, and that'll be the next video. This one took long enough. Anyway, y'all take care. Bye.